Hello there, and welcome to another graphing calculator related video. In this video we're going to be looking at the 5 different calc functions for graphs on a TI-84 Plus graphing calculator. This is dealing with the calculate screen that you'll see again and again in your course, referring to different things that you can actually calculate about or find out about a graph that you have in your graphing calculator. We're going to walk through the first 5 items. If you go to your calculator and you press second calc, which is the trace button, you'll see 7 different things you can calculate from a graph. We look at the first 5. The first one is if you're given an x value, find a y value. The second one, which says 0, is used to calculate the x-intercept of a function. Minimum and maximum both are used to find either a minimum or a maximum, or a local minimum or maximum on a graph. And the last one, intersect, is to find the point where 2 or more graphs intersect. In this video we'll walk through all 5 of these and how they work and how you have to use the calculator to get them to work. So first, given an x value, find a y value. We're going to put an equation into our calculator to play with. In this case I'm going to go to y equals, and I'm going to put in 2x minus 7. We're making the assumption in this video that you're comfortable entering in graphing equations. So I'm going to hit graph, and we're going to take a look at the graph that pops up. Now if you're asked, for example, to find the value of y when x is 3, that is the first thing you see under the calc menu. When it says value, they refer to y value. You're going to calculate a y value given an x value. So when I'm on number 1, I press enter. And the calculator is asking you, what x value are you interested in? We're interested in the x value of 3, so I type 3 and then enter. And it will tell you at the bottom the y value that corresponds to that x value on your graph. And also shows you a little cursor to show you where that's located if it's on the screen. So in this case, we know that when x is 3, y is equal to -1. I'm going to hit graph again just to get back to my plane line, and we'll go on to the next slide. Using the same equation, find the x-intercept of this function. So I'm going to hit second, the trace button, again to get to the calc menu, and I'm going to use option 2. The reason they don't put x-intercept in here and they say 0 is those two words have the same meaning mathematically. A 0 is where the value of the function is 0, which is where y is 0, which is on your x-intercept. For your purposes in this course, you can just read the word 0 in this menu as x-intercept. It has the same meaning. So to find the x-intercept, I go arrow down to option 2 and press enter. And now it's asking me left bound. Your calculator needs you to sort of narrow in on where the intercept is. This isn't as important with a straight line like we have here, but if you had a curve with several x-intercepts, this becomes more important. So I'm looking for the x-intercept here. I want to move my cursor left of that x-intercept. How much left doesn't really matter, as long as you're not closer to any other x-intercept. And as long as you're left of the one you're looking for, press enter. For right bound, you press the right arrow until your cursor goes past the x-intercept and off to the right of the x-intercept. Again, it doesn't really matter how far, just a little bit past, and press enter. And the last thing your calculator wants you to do is guess, and this is a very commonly forgotten step. You move your cursor back close to where the x-intercept is, but don't write these values down yet. Your calculator is still asking you for a guess. This is not the exact x-intercept. What it wants you to do is press enter one final time. You know you're done when it says 0. It tells you that y is 0, which it should be on an x-intercept, and your x-intercept is 3.5. So for this graph, my x-intercept is 3.5. Next, we're going to look at finding a minimum value. I'm going to erase the last equation, so I'm going to go to y equals and just press clear. And I'm going to put the equation in here. Now, the little hat means to the power of, so I'm going to type in x squared, or you can put the hat in on your calculator, x squared. Make sure to press right arrow to get down to the main line. Then plus 6x plus 10. I'm going to hit graph. Okay, I can see my graph there, and most importantly, I can see my minimum, which is the value I'm interested in. You could make a guess from what you could see off the graph, but it's always better to let your calculator calculate it for you, just in case it's a little bit off what you think it should be. So I'm going to go to second calc again, and I'm looking at option 3, minimum. This graph has a minimum because it goes no lower than that bottom vertex point. So I press enter. And again, like an x-intercept, it's asking you to do left bound, right bound, and guess. So for left bound, I move to the left of my minimum, press enter. Right bound, use the right arrow to move to the right of the minimum, press enter. And then put your cursor close to the minimum and press enter one final time. So we can see here our minimum is at an x of negative 3, but they're typically only interested in the y value at the minimum. Depends on the question. So we know our minimum is at a y of 1, and that's at an x of negative 3. Finding a maximum is a very similar thing. We have to go in and change our equation to have one that has a maximum. So we're going to use negative, make sure you use the little negative down here by the decimal point for a leading negative, negative x squared plus 4x minus 1. And again, I'm just going to hit graph and make sure we can see the maximum. We can, it's right there. And it's really the same series of steps again. Second calc, make sure you pick maximum. That's where you can make a mistake. You want to make sure to pick the appropriate min or max. So here's a maximum. And again, it's just left bound, enter, right bound, enter, and then guess, put your cursor somewhere close to the maximum and hit enter. Okay, we're getting a maximum at an x of, that's close enough to 2 to say 2, and a y of 3. The last calculation function we'll look at is finding a point of intersection. Go back into y equals, let's clear that function out, and let's put a couple functions in here. So 2x minus 1 is our first function, and press the down arrow to go to y2 and type in 0.5x plus 3. I'm going to hit graph, and you can see that these two functions cross at this point. I would like to know exactly where that point is, and that is the use of the fifth calculation function, intersect. Again, with straight lines, the maximum they'll ever intersect is in one place. If you have curvy lines, you might have lots and lots of different points of intersection. This is a little different. When you get in here, it says first curve. Calculator considers a line a curve. All you have to do for first curve is press enter. For second curve, all you have to do is press enter, and then it'll say guess. And this is important, especially if you have more than one intersection point. But you put your cursor close to the intersection point you're interested in, and again, don't forget to press enter as your final step. And it'll say intersection, telling you that you're done. And my intersection point of these two functions is an x of 2.67, rounded to 2 decimal places, and a y of 4.33. So to close, that was a quick look at the Calculate menu. You will be asked to use those first 5 functions a lot in Applied 30 and 40S. The 6th and 7th don't get used in high school mathematics. They're both calculus related things to look at on a graph, so you only have to worry about the first 5. Thanks for watching.